Hello children, welcome to the science video session. In this science video session, you are all going to learn the lesson Water from Chemistry of Standard 8. Come, let's enter into the lesson.
Unit 13 Water. Introduction. நீரின் ரமையாது உலகெனின் யார் யார்க்கும் வானின் ரமையாது ஒழுக்கு. Tirukkural says, without water there would be no life on the earth. Just like other living organisms, we also need water to survive. We need water for so many activities like cooking, washing, cleaning, and irrigation. Water resources are getting depleted nowadays because of growing demand from increasing populations and lifestyle changes. There is also a reduction in the supply of water due to pollution of water sources and climate change, which contributes to the rising variability in rainfall. We all depend on water for our living, and so every individual is responsible for saving water. In this lesson, we will learn about the sources, properties, and uses of water, and also about water pollution and water treatment methods. Come, let's enter into the lesson. First, we are going to see the composition of water. 3/4 of our planet Earth is filled with water. Water exists in three states, namely solid, liquid, and gas. Water on the surface of the earth is found mainly in oceans, that is 97.25% in oceans, then 2.05% in polar ice caves and glaciers, and the remaining is in lakes, rivers, and aquifers, then the groundwater. Even our body is made up of water, that is 65% of water, but it is not apparent, that is, it is not easy to see. Then water is a chemically stable compound. Its chemical name is dihydrogen monoxide because it contains 2 hydrogen and 1 oxygen. It can be broken up into hydrogen H2 and oxygen O2 when an electrical current is passed through it. The process of breaking down of water molecules by the passage of electric current is known as electrolysis of water. Next, we are going to see electrolysis of water. Electrolysis of water can be easily demonstrated with the help of an experiment. In this experimental setup, a glass beaker fixed with 2 carbon electrodes is filled with water up to 1/3 of its volume. The positive carbon electrode acts as anode and the negative carbon electrode acts as cathode. 2 test tubes are placed on the electrodes. This you can see in the given picture. The electrodes are connected to a battery and current is passed until the test tubes are filled with a particular gas. If the gas collected is tested using a burning splint, that means a piece of thin wood is being lit with a flame blown out. We can notice that the gas in the cathode side burns with a popping sound when the extinguished splint is brought near the mouth of the test tube. This property is usually shown by the hydrogen gas, and so it is confirmed that the gas inside the test tube is hydrogen. Next, the burning splint placed near the anode side burns more brightly, confirming that it is the oxygen gas. This experiment shows that water is made up of hydrogen and oxygen. The ratio of hydrogen and oxygen is 2:1. Hence, for every 2 volume of hydrogen collected at the cathode, there is 1 volume of oxygen collected at the anode. So, while electrolysis, the water molecule decomposes into hydrogen and oxygen gases. 2 molecules of hydrogen and 1 molecule of oxygen. If we add water drop by drop to the anhydrous copper 2 sulfate, we can notice the powder turning blue. See here, the water molecule is the reason for the color of copper 2 sulfate, and this is a test for water. Next, preparation of water. Water was first prepared in 1781 by an English scientist, Henry Cavendish. He discovered hydrogen gas when active metals reacted with sulfuric acid. The hydrogen gas released was highly inflammable and burned to form a colorless product called water. See, this is given by the equation zinc plus sulfuric acid. See here, zinc is an active metal which is reacting with sulfuric acid, gives zinc sulfate and hydrogen gas. After that, the hydrogen gas is burnt in the presence of oxygen to get water. Then, water is also produced by the reduction of metal oxide by hydrogen, burning of hydrogen in air, and burning of hydrocarbons in air. Respiration of plants and animals also releases water. See, during respiration, glucose reacts with oxygen, gives carbon dioxide, water, and energy. Do you know Henry Cavendish was a British philosopher, scientist, chemist, and physicist? Cavendish is noted for his discovery of hydrogen. He called it inflammable air. He mixed metals with strong acids and created hydrogen. He created carbon dioxide also by combining metals with strong bases. Next, we are going to see how the water is prepared in the laboratory. The laboratory preparation of water. The apparatus used for the preparation of water in the laboratory is shown in the picture. And follow the picture. In this method, pure hydrogen gas is passed through anhydrous calcium chloride to absorb water vapor if present. See, anhydrous calcium chloride is nothing but calcium chloride without water molecule. Anhydrous means without water molecule. Dry hydrogen coming out of the opening is burnt with sufficient supply of air. The burnt hydrogen gas forms droplets of water when it comes in contact with cold flask. Distilled water without any dissolved matter is obtained by this method. Properties of water. Water has some important properties which are familiar to us, but these properties are unique to water. So, we are going to see some of the physical and chemical properties of water. First, we are going to see the physical property of water, nature. Pure water is a clear and transparent liquid. It is colorless, odorless, and tasteless. Next, boiling point of water. The boiling point of water is 100 degrees Celsius at 1 atmospheric pressure. At this temperature, water boils and changes into steam. The boiling point of water increases with increase in pressure. For example, when a pressure cooker is heated, a high pressure is built inside it. The high pressure increases the boiling point of water. Thus, water remains a liquid at a higher temperature in the cooker. That is, it's greater than 100 degrees Celsius. This cooks the food faster. Do you know? Pure water has the following physical property. They are: pure water boils at 100 degrees Celsius at 1 atmospheric pressure. Pure water freezes at exactly 0 degrees Celsius at 1 atmospheric pressure. Pure water has a density of 1 gram per centimeter cube. Freezing point of water. Water freezes at 0 degrees Celsius and forms ice. Thus, the freezing point of water is 0 degrees Celsius. The freezing point of water decreases with increase in pressure. Do you know? When the skaters move on ice, they exert pressure on it. This pressure lowers the freezing point. As a result, the ice melts underneath the skate and allows the skaters to glide across the ice with a little effort. When the skaters move forward, pressure is decreased and the water refreezes to ice again. Next, density. When ice cubes are put in a glass of water at room temperature, they float on the surface of the water. This is because ice is lighter than water. It means that the density of ice is lower than that of water. When the winter temperature is below 0 degrees Celsius, the water in the lake will start freezing. The frozen ice will float at the top and cover the lake. Since ice is a bad conductor of heat, it does not allow heat to pass through it. So, the water below the ice remains in liquid form, where most of the aquatic life lives. This enables the aquatic animals and plants to survive even in extreme cold conditions. The density of water at different temperature is given in the table. First one, at 0 degrees Celsius, the density of water is 0.91 gram per cubic centimeter, that is centimeters cube. Then the density of water at 0 degrees Celsius is 0.97 gram per cubic centimeter. This is for water. The water which is in 0 degrees Celsius. Next, at 4 degrees Celsius, the density of water is 1 gram per cubic centimeter. Next, the density of water at lesser than 4 degrees Celsius is actually greater than 1 gram per cubic centimeter. So 1 cc is equals to 1 centimeters cube or 1 ml. Anomalous expansion of water. For the same mass of ice and of water, the volume of ice is more than that of water. It is an unusual physical property of water. In the Himalayas, the temperature can go down even below 0 degrees Celsius. The water in the water pipes will freeze at this temperature to ice. If the pipes are not strong, they can crack, develop leaks, or even burst. This is because freezing of water will cause an expansion in the volume. Next, latent heat of fusion of ice. Take some ice cubes in a beaker and place a thermometer in it. Now heat the beaker. The thermometer will not register any rise in temperature till all the ice melts. The question arises, where does the heat energy go if there is no rise in temperature? The heat energy is utilized in changing the state of ice from solid to liquid. The amount of heat energy required by ice to change into water is called latent heat of fusion of ice. Ice has the highest latent heat of fusion, that is 80 calories per gram or 336 joule per gram. Do you know? The freshness of fish and meat can be maintained by placing them in contact with ice. With its larger latent heat, ice is able to absorb a large quantity of heat from the fish as it melts. Thus, food can be kept at a low temperature for an extended period of time. Latent heat of vaporization of water. When water attains the temperature of 100 degrees Celsius, it starts changing its state from liquid to gaseous state. However, the temperature of water does not rise above 100 degrees Celsius. It is because the supplied heat energy only changes the state of the boiling water. This heat energy is stored in a steam and is commonly called latent heat of vaporization of steam. The steam has the highest latent heat of vaporization and its value is 540 calories per gram or 2268 joule per gram. Next, specific heat capacity of water. The amount of heat that is needed to raise the temperature of a unit mass of a substance by 1 degree Celsius is called specific heat capacity of that substance. The specific heat capacity of water is very high. 1 gram of water requires 1 calorie of heat to raise its temperature by 1 degree Celsius. Due to its high specific heat capacity, water takes time to become hot as well as to cool down. Thus, water can absorb a lot of heat and retain it for a longer time. This property of water is used to cool engines. Water is circulated around car engines using the radiator pump and the heat is absorbed. Thus, the engine is protected from getting too hot. So, water is used as coolant in car engines. Next, chemical properties of water. First, action towards litmus paper. Pure water is neutral and it shows no action towards litmus paper. Then, the stability of water. Water is a very stable compound. It does not decompose into elements when heated to ordinary temperatures. However, if it is heated to 2000 degrees Celsius, 0.02% of water decomposes to form hydrogen and oxygen gas. So, water at the temperature 2000 degrees Celsius, it decomposes into hydrogen and oxygen gases. Catalytic nature of water. Water acts as a catalyst in a number of reactions. Perfectly dry hydrogen and chlorine gases do not react in the presence of sunlight. However, in the presence of traces of water, the reaction takes place with explosion to produce hydrogen chloride. So, to the formation of hydrogen chloride or hydrochloric acid, we need moisture. So, hydrogen plus chlorine in the presence of sunlight and moisture producing HCl, hydrochloric acid. Reaction with metals. Water reacts with some metals. Metals such as sodium, potassium, and calcium react vigorously with water at room temperature. Sodium reacts with water to form hydrogen gas and sodium hydroxide solution. Due to the heat evolved in this reaction, the hydrogen gas catches fire and burns. See, the equation of this reaction is sodium with 2 molecules of water gives 2 molecules of sodium hydroxide and hydrogen gas. Then magnesium. Magnesium is a little more sluggish. That means it reacts slowly with the water, but it reacts with hot water and gives hydrogen and magnesium hydroxide solution. So the equation of this reaction is 1 atom of magnesium reacts with 2 molecules of water to give magnesium hydroxide and hydrogen gas. Many other metals react with water to form oxides and hydroxide. Iron is one such metal which forms iron oxide called rust. Iron is used in many buildings, factories, bridges, ships and vehicles. The slow and gradual rusting of iron is called corrosion. And do you know, copper does not react with water at any temperature. That is why it is used for making pipes and boilers. Reaction with nonmetals. Red hot carbon, that is charcoal, the red hot charcoal reacts with steam to produce water gas, that is carbon monoxide and hydrogen. See, the carbon with water produces carbon monoxide and hydrogen gases at 1000 degrees Celsius. Then, chlorine gas dissolves in water and produces hydrochloric acid. So, 2 molecules of chlorine gas with 2 molecules of water. In the presence of sunlight, it produces hydrochloric acid, 4 molecules of hydrochloric acid and oxygen gas. Water, a universal solvent. A solvent is a substance which dissolves other substances, that is, solute. For example, in a salt solution, water is the solvent and salt is the solute. Water has a unique property to dissolve more substances than any other solvents. It can dissolve solids such as salt and sugar, liquids such as honey and milk, and gases such as oxygen and carbon dioxide in it. Therefore, it is called as universal solvent. Let's say the activity related to the solids dissolved in water. We are going to find out the solid dissolved in water. For that, first we should place a sample of tap water on a clean watch glass, and we should place it over a beaker containing water as shown in the picture. Then we should boil the water in the beaker. When all the water has evaporated from the watch glass, should remove it from the burner and we should let it cool. What do we observe? We can see a number of concentric rings of solid matter deposited on the watch glass. These are the dissolved solid left behind after the evaporation of water. Salts, minerals, and impurities are the dissolved solids in water. Dissolved salts are important for the following reasons. They are essential for the growth and development of plants. They add taste to water. They supply the essential minerals needed for our bodies. Most of the chemical reactions important for our living takes place in the cells of our body with the help of water. And do you know? Tap water, river water, and well water contain dissolved solids. But rainwater and distilled water do not contain dissolved solids. Hence, concentric rings are not formed in the rainwater and distilled water after evaporation. Apart from solids and minerals, air is also dissolved in water. Air is present in dissolved state in all natural sources of water. The solubility of oxygen in water is higher than the solubility of nitrogen. Air dissolved in water contains approximately 35.6% oxygen along with nitrogen and carbon dioxide. Air being dissolved in water is important for the following reasons. They are: air dissolved in water is important for the living organisms to survive. Fish extracts the oxygen from the water and expels water through the gills. Fish can survive in water only through the dissolved oxygen present in water. Aquatic plants make use of dissolved carbon dioxide for photosynthesis. Carbon dioxide dissolved in water reacts with limestone, that is calcium carbonate, to form calcium bicarbonate. Marine organisms such as snails, oysters, etc., extract calcium carbonate from calcium bicarbonate to build their shells. Let's see an activity how the oxygen is dissolved in water. Take a beaker and fill it half with fresh water, fresh tap water, and heat it. You will see small bubbles appearing on the sides of beaker long before the water reaches its boiling point. These bubbles are oxygen gas dissolved in water. Potable water. Imagine you are swimming in the sea and by accident you swallow some sea water. How would you feel? You would probably feel like vomiting, isn't it? The sensation of feeling nauseous is because of a lot of salt in the water. Every liter of seawater contains 35 grams of dissolved salts, most commonly known as sodium chloride NaCl. Such water is called saline water. It is not suitable for drinking and is said to be non potable water. And the water suitable for drinking is called potable water. Every liter of potable water contains 1 to 2 grams of dissolved salts, mainly common salt. In addition to the common salt, there are small amount of calcium Ca, magnesium Mg, potassium K, copper Cu, and zinc Zn. The minerals in water gives it a certain taste. In addition, these minerals are useful for our body's metabolism. Potable water also contains dissolved gases. Do you know about the Dead Sea? The salinity of water is more in the Dead Sea. It is actually salt lake as it has a single source of water and is not connected to the ocean. It is landlocked and this causes the water to evaporate. This has led to a steady increase in its degree of salinity. Now, the salinity is so high such that the marine life cannot survive in it. This is why it is called the Dead Sea. Characteristics of potable water. The following are the characteristics of potable water. Potable water should be colorless and odorless. It should be transparent. It should be free from harmful microorganisms such as bacteria, virus, and protozoa. It should be free from impurities such as suspended solids. It should contain some minerals and salts necessary for our body and some dissolved gases to add taste. Purification of water. Out of the total fresh water available on the earth, only 1% is present in water bodies such as rivers and lakes, and the rest is frozen in glaciers and polar regions. Water from these water bodies is unfit for drinking, cooking, washing, or bathing because it contains suspended and dissolved impurities. It also contains microorganisms such as bacteria. If this water is consumed without purifying, it can cause waterborne diseases such as typhoid and cholera. Therefore, water should be treated and purified before it reaches our home. In conventional water treatment plants, water is subjected to different process for purification. Let's see this process one by one. And do you know every year 4.6 million children die due to diarrhea? Access to clean water improves hygiene and health. In the process of purification of water, first we are going to see the sedimentation. Water from lakes or rivers is collected in large sedimentation tanks. There it is allowed to stand undisturbed so that suspended impurities settle down at the bottom of the tank. Sometimes a chemical substance such as potash alum is added to water to speed up the process of sedimentation. This process is called loading. The particles of potash alum combine with the suspended impurities and make them settle down at a faster rate. Next method, filtration. Water from the sedimentation tanks is then pumped to the filtration tanks. Filtration tanks contain filter beds made up of gravel, sand, pebbles, activated charcoal, and concrete. Water passes through these layers and becomes free from any remaining dissolved or suspended impurities completely. The next important process, sterilization. The filtered water is treated chemically to remove the remaining germs or bacteria. This process is called sterilization. The chemicals that are used in this process are chlorine and ozone. The water from filtration tanks is pumped into the chlorination tanks where chlorine is added to remove harmful bacteria and other germs. The process of adding chlorine in adequate amounts to water is called chlorination. Ozonization is a process in which water is treated with ozone gas to kill the germs present in it. The sterilization of water can also be done by exposing it air and sunlight. Oxygen from the air and sunlight destroy the germs present in water. Aeration is a process in which air under pressure is blown into filtered water and this helps to kill the germs. Do you know about RO purifiers? RO purifiers are the purifiers that can remove the dissolved impurities and germs. They also improve the taste of water. RO stands for the name of the technology, reverse osmosis, used in these purifiers. Some RO purifiers also have a UV unit, ultraviolet unit, that destroys the germs present in the water. Hardness of water. We use soaps and detergents to wash clothes. They form lather, that means the foam, with water that quickens the process of removal of dirt from the clothes. Water contains a number of dissolved salt and minerals. When these salts are present in very small quantities in water, it is called the soft water. In this water, soaps or detergents form lather easily. That means it produces foam easily. Sometimes minerals and salts are present in water in such a large quantity that soaps or detergents form a thick precipitate called scum. That means a layer of dirt instead of forming lather. This makes the removal of dirt further difficult. Such water is called hard water. Hardness of water is due to the presence of dissolved salts of calcium and magnesium. Hardness may be temporary or permanent. Temporary hardness is due to the presence of carbonate and bicarbonate salts of calcium and magnesium, and permanent hardness results due to the presence of chloride and sulfate salts of calcium and magnesium. Disadvantages of hard water. It is not good for washing clothes. It forms scum with soaps and detergents, which makes the soap ineffective and also spoils the clothes further. It damages the utensils and containers in which it is stored and forms a hard layer. It forms scales on the machine parts used in industries and decreases their efficiency. This you can see by the given picture. And it results in stomach ailments if consumed for a long period. Removal of hardness. Different methods are followed to remove the hardness from water depending on whether it is temporary hardness or permanent hardness. First, we are going to see the first method of removal of hardness, boiling. Temporary hardness is easily removed from water by boiling. What is temporary hardness? Temporary hardness is due to the presence of carbonate and bicarbonate salts of calcium and magnesium. Okay, so when heated, the calcium hydrogen carbonate decomposes producing insoluble calcium carbonate. The insoluble carbonate are then filtered and removed from water. This makes the hot water soft and fit for use. The next method of removal of hardness is adding washing soda. Washing soda is used to remove permanent hardness of water. Adding washing soda converts chlorides and sulfates into insoluble carbonates. These insoluble carbonates are removed by filtration. The next method is ion exchange. Another method used to remove the hardness of water is to pass it through a column of ion exchange resins where calcium and magnesium ions get replaced by sodium ions. This converts hot water into soft water. Next, distillation. Temporary and permanent hardness both can be removed by the method of distillation. The water obtained after distillation is called distilled water. It is the purest form of water. Distilled water and boiled water have no taste. The pleasant taste of drinking water is due to the presence of dissolved substance in which include air, carbon dioxide and minerals. Water pollution. Contamination of water bodies as a result of human activities is known as water pollution. Contamination of water bodies occur when harmful substances such as chemicals, sewage and waste are released into them. It produces physical, chemical and biological change in the quality of water. It degrades the water quality and renders it toxic to living organisms. Drinking polluted water has serious negative effects on human health. Water resources in Tamilnadu. Freshwater resources are the sources of water that are useful to society for domestic, agricultural, or industrial uses. These include surface and groundwater. Example of surface water include river, reservoir, lakes and tanks. There are 17 major river basins in Tamil Nadu with 61 reservoirs and approximately 41,948 tanks. Lakes and tanks are traditionally used in Tamil Nadu to collect rainfall during monsoon, which can be used throughout the year. Groundwater sources are called aquifers. Aquifers are layers below the ground made of coarse and sand and gravel that contain space allowing rainwater collection. The use of groundwater is possible through open wells and bore wells. Sources of water pollution. When you look around, you can see polluted water bodies in your surroundings. You can see a lot of unwanted and harmful substances such as waste and sewage thrown into them. These substances are called pollutants. These pollutants are released by various activities from different sources. In general, sources of water pollution are classified as natural sources and man-made sources. Come, let's see that. In sources of water pollution, first we are going to see household detergents. Household and cleaning detergents are a major cause of water pollution. Synthetic, that is non-biodegradable detergents have chemicals that do not break down and can end up polluting both surface and groundwater. Excessive use of detergents adversely affects fish and other organisms. Some shampoo, face wash, shower gel, and toothpaste have small round pieces of plastic added to them. These are called microbeads. They are added for different reasons like scrubbing and cleaning your skin, polishing your teeth, etc. When we use products with microbeads, they go down our drain and pollute water bodies. Fish and other animals feed them by accident and get sick. Next, domestic sewage. Wastewater that is disposed of from household is known as domestic sewage. Domestic sewage should be treated before being disposed of into water bodies like river, lake, etc. Untreated sewage contains impurities such as organic matter from food waste, toxic chemicals from household products, and it may also contain disease causing microbes. Do you know? The largest source of water pollution in India is untreated sewage. On an average, a person uses 135 liters of water per day for washing clothes, cooking, bathing, etc. Domestic waste and plastics. Solid waste including plastics are disposed of or end up in the water bodies such as lakes, rivers and the ocean. Plastic blocks drains, spreading vector-borne diseases such as malaria and dengue. Waste in water bodies negatively impact aquatic life. Agricultural activities. Fertilizers, pesticides, and insecticides used in agriculture can dissolve in rainwater and flow into water bodies such as river and lakes. This causes an excess of nutrients such as nitrates and phosphates as well as toxic chemicals in water bodies. It is called eutrophication. These substances can also be harmful to aquatic life. And do you know plastic sheets are used in agriculture to grow vegetables? At the end of the season, these plastic sheets are plowed back into the soil. The plastic sheets break down into tiny pieces and get eaten by earthworms, which is harmful to their health and that of soil. Industrial waste. Many industries release toxic waste such as lead, mercury, cyanides, cadmium, etc. If this waste is unregulated and is released into water bodies, it has huge impact on humans, plants, animals, and aquatic life. Next, Oil spills. There are large crude oil and natural gas reserves below the seabed. With the increasing exploration of crude oil in the oceans, accidents in drilling and transporting oil have also increased. Oil spills cause water pollution, which is harmful to aquatic life. The oil, which remains floating on the water surface, blocks sunshine, reduces dissolved oxygen in water, and suffocates marine organisms. Next, thermal pollution. Large amount of water is used for cooling purposes in thermal and nuclear power plants and many industries. Water used for cooling purposes is discharged back to a river or to original water source at a raised temperature and sometimes with chemicals. This causes a rise in temperature and decrease the amount of oxygen dissolved in water, which adversely affects the aquatic life. Common pollutants. Pollutants are generally classified as domestic pollutants, agricultural pollutants, and industrial pollutants. The source and effects of various water pollutants are shown in the table. First, we are going to see the domestic pollutants. The source of domestic pollutants are detergents, plastic clothing, and hair, beauty, and skin products. First, detergents. The pollutants inside the detergents are sodium sulfates and phosphates. And the effect of these pollutants are in human they cause developmental, reproductive and neurotoxicity and endocrine disruption. Phosphates make bacteria and algae grow faster and use up all the dissolved oxygen. This leads to decrease in animal and plant diversity. Next, plastic clothing and hair, beauty and skin products. So the pollutants inside that are plastic fibers and microbeads. These ends up in water bodies such as lakes, rivers and the ocean. Here they attract toxic animals, toxic chemicals. Marine animals often eat them as they confuse them as their natural source of food, and the toxins can move up the food chain. Next, we are going to see the agricultural pollutants. The source of agricultural pollutants are insecticides and fertilizers. First, insecticides. The pollutants inside the insecticide is DDT, dichloro-diphenyl trichloroethane. The effect of this pollutant is it affects the central nervous system of insects, animals and humans. It accumulates in the food chain and impacts the top predator the most. Next, fertilizers. The pollutants inside the fertilizers are nitrates and phosphates. The effect are bacteria and algae grow faster and they use up all the dissolved oxygen, and this leads to a decrease in animal and plant diversity. Next, industrial pollutants. The source of these pollutants are chemical, textile and leather industries and leachate from open dumping of solid waste. The pollutants are lead, mercury, cadmium, chromium and arsenic. The effect of these pollutants are toxic to animals, plants and bacteria in the water, pollutes potable groundwater, negatively impacts human health. Do you know? Microplastics can be found in almost every freshwater source. They have been found from the freezing water of the Arctic and Antarctic to the bottom of the deep sea floor up to 5,000 meters deep. Microplastics have been found in bottled water and tap water around the world. Controlling water pollution. Water is precious and it is essential for all living organisms. But today, almost every water body is polluted with waste ranging from plastic to toxic substances. All of us can take immediate steps to save our precious water bodies from pollution. Some simple ideas to avoid water pollution are: use detergents that are biodegradable and avoid those that contain toxic chemicals. Wear clothing that is made from natural fibers such as cotton and avoid wearing synthetic fibers such as nylon, polyester, etc. Do not throw waste such as plastics into water bodies. Always separate your waste into recyclable, non-recyclable and biodegradable so that it does not cause pollution. Domestic waste water should be treated properly and all harmful substances should be removed from it so it can be reused for flushing toilets and gardening. Use biopesticides, that is natural pest control, instead of chemical pest control. Use compost made from cow dung, garden waste and kitchen waste as a fertilizer. Water released from industries should be treated before being discharged or recycled for industrial purpose.